In this iMachining tutorial series, part 1 of video 4, we will define examples of closed pocket geometries. These include a simple closed pocket, a closed pocket with island, a closed pocket with multiple islands, a closed pocket with entry, a closed pocket with entry hole, a closed pocket with island and entry hole, and a closed pocket with multiple islands and entry hole. Before we begin, please note that this SolidCAM part file called geometrypart1.prz is included with this video tutorial. Like shown in video 1 of the series, this part file was saved in the training folder that we've created on our C drive. Now let's open SolidWorks. Go to the SolidCAM drop-down menu and select Open. When the dialog opens, let's look in the C drive under Computer. Select the training folder from the list, and then choose the Geometry Part 1 and open it. Like prepared in the previous video, a new CAM part has already been created for these upcoming geometry exercises. We will be running SolidCAM in a CAM experimental mode, which disables the auto isometric view. This can mean a lot less panning and zooming of the part between operations. If you prefer working in this style, you should call your SolidCAM support technician for help setting this up. First, we are going to create a new iMachining operation. All the examples will use the same tool and have the same depths. For each geometry example, we will simply save and copy the operation and define the next geometry example. The first example will be a simple closed pocket. Using auto constant Z will close the geometry. For each example, we will simulate the wireframe toolpath in HostCAD after the calculation. Also, I will point out some of the iMachining techniques on the different geometries. On this closed pocket, iMachining will use the helical data from the operation to enter into the pocket, followed by a morphing spiral to the outer edges. Now, let's click Save and Copy to create a new operation with the same settings. The new operation will automatically open. Every time we define the next geometry example, it is important to first delete the name of the previous geometry, then click Define. This next example is of a closed pocket with island. Once again, auto constant Z is used to close the geometry. In HostCAD, we can see the helical entry followed by a moat to separate the island from the remaining material, where a morphing spiral can then be formed. Again, we will save and copy the operation to adopt the same settings as before. We just need to choose the new geometry for the next example. This example is of a closed pocket with multiple islands. There are 2 islands in this example, but an unlimited number of islands can be defined. In HostCAD, we can see that each island is separated when encountered, and a final morphing spiral is formed. Then, we simply click Save and Copy again and define the geometry for the next example. This example is of a closed pocket with entry geometry. By right-clicking on the geometry name and selecting Mark Chain as Open, this will inform iMachining that this geometry is for entry and is not an island. Any shape can be used as entry geometry as long as it falls inside the closed pocket. In HostCAD, we can see that a morphing spiral is formed from the entry geometry to the outer walls of the pocket. Let's save and copy the operation and define the geometry for the next example. This example is of a closed pocket with entry hole. This shows how to define an entry hole that was drilled. Marking the entry hole as open allows the tool to feed down into the hole. It is important to note that if the pocket has a flat bottom, the hole should have a flat bottom also, since the tool will be fed down to the bottom of the pocket. A contour operation can be used to remove the drill point from the bottom of the hole before using iMachining. Let's look at the tool path in HostCAD. Now, let's save and copy the operation again and define the geometry for the next example. This example is of a closed pocket with island and entry hole. Again, marking the entry hole as open allows the tool to feed down into the hole. In HostCAD, we can see that the island is separated from the remaining material. Finally, let's save and copy the operation and define the geometry for the last example. This example is of a closed pocket with multiple islands and entry hole. In HostCAD, we can see that the tool feeds down into the hole and both islands are separated as they are encountered. And this concludes part 1 of video 4 of the iMachining tutorial series, where we have defined examples of closed pocket geometries. Thanks for watching. Please join us for part 2 of video 4 of the series, defining open and semi-open pocket geometries.